Hey there, tech enthusiasts. Welcome to Z Tech Advisor channel in a series of CASP Plus course videos. Today, we're diving into the exciting world of scalability. Now, you might be wondering, what is scalability and why is it important? Well, imagine building a house. You start with a solid foundation, then add walls and a roof. But what happens when your family grows? You can't just keep adding rooms haphazardly. That's where scalability comes in. Scalability is all about ensuring that your system can accommodate more users or more traffic without breaking down. It's like having a blueprint for your house that allows for future growth and expansion. When you design something with scalability in mind, you're setting it up to handle more people or more traffic in a structured and sustainable way. When I talk about scalability is measured by the number of requests an asset or server can effectively support simultaneously. Essentially, when the system or application can no longer handle additional requests effectively, you have found the limits of that system's scalability. In traditional networks and servers, this occurs due to the limitation of processing capability or the amount of physical memory, or even the amount of network bandwidth that you may have available. Now, if you begin to run out of resources when trying to support requests from users, then you need to scale up or scale out to increase those resources and therefore be able to support the additional request. Scaling up is known as vertical scaling. Scaling out is known as horizontal scaling. Let's take a quick look at each of these. Vertical scaling refers to adding more resources such as more processing power, more memory, more storage, or more bandwidth to your existing machine. For example, in my laptop, I have 16 gigabytes of RAM. Now, if I find the system starts slowing down when I open really large files, I may need to increase my available memory, and I could do that by adding an additional 16 gigabytes of RAM, bringing my total up to 32 gigabytes of RAM. This is a really simple example of scaling up or using vertical scaling going from 16 to 32 gigabytes in the same system. Now, this is very popular in traditional systems and networks, and it can also be done when you're using cloud services as well. For example, let's pretend for a moment that you're going to start a new blog and you decide to use a simple cloud solution like Amazon's Lightsail to host that blog. Well, you might start out with the $5 per month plan. And this has 1 gigabyte of memory, a single core processor, 40 gigabytes of disk space, and 2 terabytes of data transfer each month. Now, over time, you start to gain more readers to your blog and you realize you need to scale up vertically. So you click a button and you upgrade to the $20 per month plan. This now gives you 4 gigabytes of memory instead of 1 gigabyte of memory. It also doubles your processors and disk space. And now your data transfer allowances will also to go up. All of this went vertically scaling by giving you additional resources. Now you can keep scaling up vertically until you reach the largest plan size, which at the time of this filming is around $160 per month. That plan would give you 32 gigabytes of memory and 8-core processor, 640 gigabytes of disk space, and 7 terabytes of data transfer per month. But what do you do when you can't vertically scale anymore, but you're still getting more and more readers to your fabulous new blog? Well, you're going to need to re-architect your website to allow for horizontal scaling, also known as scaling out. Now you see vertical scaling is really easy because you don't have to recode or redevelop anything on your website at all. Instead, you just add more memory or more processors or more bandwidth, and you're still using a single machine, this virtual machine, to do all of your processing. And that is how you initially designed your website. So scaling vertically is really easy. But with horizontal scaling, we now have to require us to break down that workload into smaller pieces of logic that can be executed in parallel across multiple machines. If you're using a database to run your website, horizontal scaling will allow you to partition the data across multiple databases so that each database only contains some of that whole data. For example, let's go back to using the example of the blog. You might have a collection of thousands of different articles split across multiple servers. one for each year of the different articles you wrote during that year. Now, when somebody wants to read one of the articles, it's going to get answered by the corresponding server and database based on the article year that was being requested. In general, scaling out is going to be better for the long term because each individual machine is cheaper to add than using scaling up. Now, scaling up is going to be more expensive because you're doing more on a single machine and you're adding additional resources. And that doesn't scale up nearly as well as scaling out does. Additionally, when you scale out, it becomes virtually limitless because you can keep adding smaller, inexpensive machines to meet the increasing workload that's being caused by all these additional users and their requests. By focusing on horizontal scaling, you can become infinitely elastic, and your only limit really becomes your ability to pay for cloud computing time from your cloud service provider. By using horizontal scaling and scaling out in this manner, you can have instant and continuous availability, no limit to hardware capacity, cost that's going to be assessed on a per-use basis, built-in redundancy, and it is going to be easier to size and resize to meet your needs. Now, the challenge with horizontal scaling is that you need to design your applications to work in smaller, self-contained blocks that interact to create the results you need. To do this, your application has to be designed as a stateless app on the server side. Therefore, it's going to be able to be divorced from any single server for long periods of time. Anytime your application has to rely on server-side tracking of what it's doing at any given moment, that's going to require a user session be tied to a particular server. If, on the other hand, all session relays specifics can be passed seamlessly across literally hundreds of servers, that's going to allow us to infinitely scale out much quicker. The ability to hand a single session or thousands or millions of single sessions across multiple servers interchangeably is at the very epicenter of horizontal scaling. To do this, you always want to focus on using service-oriented architectures, or SMA, whenever you're building for horizontal scaling. By using microservices and developing your application for independent web, application, caching, and database tiers, you could scale each of these blocks independently as needed to meet your increasing loads and demands for your services, and be able to infinitely scale outward. Let's consider the global e-commerce giant, Amazon. Amazon's platform must handle millions of transactions, customer interactions, and data requests every day. To manage this massive scale, Amazon employs horizontal scaling. In the early days, Amazon's infrastructure was not designed to handle the vast number of requests it receives today. As the company grew, it became clear that vertical scaling alone would not suffice. Amazon began to re-architect its systems into a distributed, microservices-based architecture. This allowed different components of the Amazon website to scale independently. For example, the checkout service can scale up during high-traffic events like Black Friday, while the product recommendation service might scale differently based on browsing patterns. Moreover, Amazon Web Services, AWS, a subsidiary of Amazon, provides a clear example of horizontal scaling. AWS offers cloud computing resources that allow businesses to scale out their applications across multiple servers in the cloud. This means that a startup can begin with a small, inexpensive cloud server, and, as their user base grows, they can add more servers or shift to more powerful ones without significant downtime or re-architecture. This approach to scalability ensures that Amazon can continue to provide a seamless shopping experience, even during peak times, and maintain its reputation for reliability and customer satisfaction. It's a testament to the effectiveness of horizontal scaling in meeting the demands of a rapidly expanding digital user base. And that's it for today's tutorial, folks. Hopefully, you found this guide helpful. Don't forget to like this video if you enjoyed it and subscribe to our channel for more tech tips and tricks. Thanks for watching, and until next time.